in cell B2. To make it visible, let me magnify it. Okay, so amount of loan, for the time being we assume it to be like 5 lakh, and we may format this cell, as choose currency. For negative numbers we can choose rate and amount of loan. Thereafter, amount of loan, we have annual rate of interest. Annual rate of interest we can assume, just take for example 10%. After that, repayment duration, like how many years it takes to repay the loan. So repayment duration in years. So we enter it. We enter 5 years, like 5 years. In 5 years all the loan is repaid back. Then we have periodicity of installment payments, like quarterly or half yearly or bi-monthly. So we'll enter that later. For the timing we just write periodicity. Thereafter we write IMT, interest rate per period. Like period here means one period is like the interval between two installment payments. So in quarterly, the one period consists of 1 quarter, 3 months. If a loan is repaid on monthly basis, so interest rate per period here means each period is of just 1 month, and interest rate per period would have to be calculated in case of monthly payments by dividing annual rate of interest by 12. If periodicity is quarterly, that is there are 4 installment payments in a year, then the annual rate of interest has to be divided by 4 to get interest rate per period for quarterly payments. And here we enter number of installments. This is also same as infer of the PMT function. Here we would be using this PMT function. So as you already know about the PMT function, here the arguments we can see it like this is infer number of installments, this is rate, and this is repayment, this is PV, and so these are PV, rate, and infer. These are mandatory or required arguments for the calculation of installment amount. The future value will enter that as 0 because we want all the loan to be repaid back, no balance left. So after the payment of last installment, that we would enter FV as 0. So the required argument are there, PV, rate, and infer. For periodicity, we will just write some list and the factors. So we start right, we just enter it here, bi-monthly, then half yearly, monthly, quarterly, and yearly. If you want to have more frequent payments, then you can do that, but for the time being we are just having this 5. And in bi-monthly, if we are paying it bi-monthly means every 2 months we are paying, then there would be 6 installments in a year. If you are paying half yearly, then there would be just 2 installments. In case of monthly, we'll be having 12 installments. In quarterly, we'll be having 4 installments, and in yearly we just have 1 installment in a year. So one thing here I want that for periodicity, here I want a drop down list of these 5, and then this factor 6, 2, 12, 4, and 1 would be used to get total number of installments as well as the interest rate per period calculations. So for periodicity, what we do that we use data validation. In data validation, in the allow box we choose list. In the source we choose this from bi-monthly to yearly here, and we click OK. So here we get all this drop down list, so a user can choose any of this. Okay, so periodicity is taken care of now. For interest rate per period calculation, we need this factor and we need this factor. So now for calculation of number of installments, like if the repayment duration is 5 years and we choose quarterly option, like quarterly, so there would be total of number of installments would be 5 into 420. So when a user chooses quarterly, we want this to be calculated automatically here, and that we can do by using a VLOOKUP function. And so we choose by what factor we want to multiply it. Just enter a factor here, and factor would be this cell would show some output using VLOOKUP function. Lookup value is this quarterly. The table array is this list of periodicity and the factors, then comma, and we want output from this column 2 of this table array, so we choose 2 and then we close it. And here, so for quarterly we are getting this 4, like 4 installments would be there if we are paying on quarterly basis. If we choose monthly, then it's 12. If we choose yearly, then it's 1. So now using this factor 1, we can calculate total number of installments, and that would be equal to repayment duration in years multiplied by this factor. So number of installments would be 5 if we are paying it yearly, when repayment duration in years is 5. If we choose quarterly, then it would be total number of installments would be 5 into 4 is equal to 20. And this total number of installments is same as the input of the PMT function. Interest rate per period calculation, we enter equal sign and then annual rate of interest divided by this factor, and so here we get 0.025. We can format this cell as %. So format cells and just choose percent. It comes to be 2.5%. So interest rate per period in case of this quarterly payment would be 2.5%. Now we have to show here installment amount. Installment amount, and installment amount for this you'd be using the PMT function that I have already described. So equal sign, then PMT. Rate we are getting from here, rate. Infer we are getting this number of installments is 20. Then PV, present value, that is the amount of loan at present time, is this. We want the future value. Even if we leave this would be treated at 0 balance at the end of the repayment period. Still we just enter 0. And type, for type we have two options. We can enter 0 or 1. So 0 means that interest is supposed to be paid at the end of the intervals or end of the period, and 1 would mean that interest would be paid at the beginning of the period. So we just take normal thing that we choose it 0, that interest would be paid after a particular duration. Like if we are paying it quarterly and on quarterly basis, then and the loan we have taken on 1st April, then first installment would be paid at the end of this first quarter, April, May, June. So 30th June may be taken as the time of payment of first installment. So this function is there. Here we are getting a negative value and this shows that this is cash outflow kind of thing, so that's why it's shown as negative. We can format this cell and choose without the negative sign, just red, it would be marked in red, showing that that is the installment amount, that is cash outflow. So we have got, using PMT function, this installment amount, and now we are ready for what we have started this whole thing exercise, and that is for creation of generalized loan repayment schedule. So here we enter loan repayment schedule. We have we enter here period, then opening balance, then interest due, thereafter we have installment amount, then here we can also get principal amount, principal component, and then closing balance. Closing balance. So we have got this closing balance. Here for first installment we can enter just one. Opening balance. Opening balance when would be equal to this value, this amount of loan. So we enter it here, equal sign, and then this. So opening balance comes out to be rupees 5 lakh. Interest due. For this you would be using the IPMT function, and IPMT function is, again we are getting rate from here. One additional argument here is period. This figure we would be getting from this A12. NPER would be get from C7 cell. PV we would be getting from this. Present value would be getting from this part. AB as 0, and this as again type is again as 0. So this we get IPMT. We format this cell again to exclude the negative sign. Then installment amount would be same as this one. Principal, for principal we may use PPMT, or just we can do it by reducing or just we use PPMT function, PPMT rate from C6 cell, period from A12, PV from this place, 0, 0, and this, and close. So here we are getting, for calculation of principal component, we would be using PPMT function. We get this argument rate from C6 cell, then period from A12 cell, NPER from number of installment cell, PV from amount of loan, this C2 cell, then 0 for FV and 0 for type. So we get principal here, again removing this negative sign. So here 19,573.56 is the principal amount, and closing balance would be equal to opening balance minus principal. So when we are reducing this principal amount from opening balance, we are actually, closing balance is getting increased. Here it is being done so because this is negative value, and if you reduce a minus thing, that gets plus. So in the formula we edit it here, and instead of minus sign we enter plus sign, then we get closing balance. Now we want such a thing that when we choose here a different thing, here we can see the various calculations are automatically being done, but the number of installments is just being shown as 1, and we want such a thing that if we choose yearly, then number of installments 5 should be shown, and if we choose monthly, then number of installments 12, the details should be shown. And that we can do it here by entering here equal sign. We use here if that unnecessary details are not shown, so we use if function here, and we just compare this cell that if C2 is less than number of installments, total number of installments, then the value output we want here just for the next period is 1 plus 1, so this plus 1 comma, and this is a blank space, and we enter it here, so we get 2 here. This opening balance for the second period would be the closing balance of the previous period, so it would be easy to write just equal sign and equal sign, then this we get closing balance. But we want that suppose the payment duration we make in years 1, and here also we make yearly, so we don't so there should be just 1 installment, so we don't want these things to appear here. This should be clear, so that's why we would be entering some, again using if formula we can take care of that. So here we use enter if, then if this cell is equal to blank, then this cell is also blank, otherwise this should give the output of this closing balance. So here we get this interest due would be equal to for interest calculation, again we use if statement. If this cell is equal to blank, then this is also blank, otherwise interest due can be calculated by this IPMT function. IPMT is rate infer, now this is rate and period, then infer, then PV, then AB is 0 and this is 0, and this enter close. We found a typo in the formula. Do you want to accept this correction? Yes. Okay, yes. There should be one more bracket. So here again we format this cell as format cells. We make it a currency, this part, and installment number of yearly. Let's make it quarterly. Installment, for installment again we use if function. If this cell is equal to blank, then this is also blank, otherwise the installment amount would be equal to this part and this. Now when we drag this down, this would change E3 to E4 or E5. We don't want to do that, so we enter dollar here. Okay, here again we can format this cell. For formatting cell we can do one thing. We can go here this format printer part, we click, and then we click here and here, so this formatting is copied. Then for principal calculation for the second period, we again use if function. If this A13 cell is equal to blank, then blank, otherwise we use PPMT function. PPMT function is arguments are again rate, then this particular period, then infer, then present value, then future value is 0 and type is 0, and then this and one more bracket and enter. For closing balance, we write again the if function. If this cell is equal to blank, then this is also blank. Otherwise, for closing balance, we get opening balance minus this principal amount and bracket close. We get this. Let's comment this cell also. Comment cells currency and okay. Oh, again we are not supposed to minus this. We need a plus sign. So this is plus. So that is. Now let's review the formula that we have entered. This is right. There would not be any problem with this. Here we are referring to cell if A12 is less than C7. So C7 we need to reference it so that it doesn't change. C7 is here, so we make it C$7. For opening balance calculation, F12 we have referred it to F12 and that may change, so it is fine. For IPMT calculation, interest payment, we need to enter some dollar thing. So C6, the rate should be referred to the same cell, so we put a dollar here. A13 periods should change, infer should not change, preferred cell, and PV should not change, so we put dollar. For installment calculation, we have already given a dollar here. For principal calculation, rate is there in the specified cell, so we need to fix it. A13 that may change, that needs to change. Infer we need to fix it, so we put a dollar. For C2 present value we also put a dollar, and then this. So now let's see whether we have done it well or not. We select this 2 and second row and then we drag it all and we go till here. Let's go to the stop till 60 so far, and we can see that prima facie it seems that it is calculating the things well. As you can see here that total number of installments is 20, and at the end of this period this amount comes to equal to 0. So the beauty of this thing, that what we have done in the second row is that if the repayment duration is in years 5 and periodicity we choose to be yearly, then there should be just 5 installments. So this 5 is there, and after 5th installments we don't have this. So we have done it right. Now again we can drag this 12 part thing to so that it takes care for various values. So let's drag it till 158th row. That would be enough. So 158th row, and that we have completed the exercise. You can change various values. You can annual rate of interest can be changed. Let's make it 14%, and even for 14% we can get these calculations. So you can do it now. This can be deleted. We don't need it. You can change these things, make some kind of format it, like you can use borders. So we can choose borders. We can do some decorations, choose slightly different color. So that is there. Now you can do on your own. Thank you.